list cycle. It's an easy question, so hopefully it won't be too bad, but that hasn't stopped me from going in circles before. So we're given the head of a linked list to determine if we're given a head, and we have to determine if a linked list has a cycle in it. A linked list is a cycle in a linked list. There's a cycle in a linked list if there is some node in that list that can be reached again by continuously following the next pointer. And internally, position is used to denote the index of the node, and the tails next pointer to pause is internally position is used to denote the index of the node that tails. Okay. I don't know what the point of this pause thing is, but essentially we're required to check if there's a cycle in the list. So let's write the inputs outputs. So what is head? List node can be null. No, sorry, none. Output if loop exists or not. Boolean. Okay. So I'm just thinking 2 pointers. Slow and fast, right? Fast pointers, right? So logic between slow and fast pointers: one pointer increments by 1, another increments by 2. So if these pointers reach each other, then there is a loop. Else, if one of them reaches none, then there is no loop. Right? If one of these pointers, if the fast pointer can reach none, then there's obviously no loop. And I was thinking, like, what if there's like multiple loops in this linked list, but it's not like it branches off. If there's multiple loops, let's say like it was 4 and then something else, and then loops back here, these slow and fast pointers will only catch us first, right? You don't ever go past that. Or no, not even like this, but if there's 3, 2, 0, and then this loop goes back to this 2, I guess it's not part. There's only one loop. Okay, never mind. I ignore that. So logic behind it is, if head is none, return. What is there any proof? Oh, I guess position is used to, like, if you want to check the number of the index of the nodes. I guess valid. I don't know what the whole point is. Position is, but whatever. So return false. Else slow is equal to head. Fast is equal to head. Well, fast dot next. Fast dot next is not none. And fast dot next not none. Increment by 1, increments fast by 2. If fast and slow are equal, return true, right? We want to return true if loop exists, false if loop doesn't exist. So we want to return true here, else return false here, right? So if we are exiting out of this loop, that means that one of these hit none, and we can return false. I logically, I don't think we need to handle like slow in this while loop, because this fast will always be ahead, right? So it'll like almost like clear all the unknown on the path. So this slow is always running behind this fast. So if fast will be able to go ahead, then we don't have to worry about slow hitting a none point. So with that, let's get started. So if head is none, return false. slow is equal to head, fast is equal to head. So while fast dot next not equal to none, and fast dot next not equal to none. Slow dot next, fast is equal to fast dot next. Fast dot val is equal to slow dot val, return true, return false, right? We can guarantee that this will at least be true in the first iteration because if head was none, this will throw an error, but if it is not none, then we can still access a pointer here, and then this won't throw an error, but this should return false. I think this is fine. So let's go to an example. So in this, let's do at least a simple example. All right. So a simple example was examples is 1 point to 2 and then points back to. We're doing it like this, right? So you have fast here and slow here, and so you have one here, and then slow goes here, slow is here, and then fast is here, and then you increment by 2 again, so then slow becomes this, and then fast rotates back into here. Val is the same, and then that. Okay, cool. We have then 3 points to 2, points to 0, points to -4. And we also guarantee that I guess okay, one thing I'm immediately realizing is val could be duplicate, right? We could have 3 and 3, so I'm going to assume that that's not the case, but if that is the case, then we can fix that, I think, just by removing this val. I think, well, let's just try that, and then let's run this, and I think this works basically. Okay, I think that works, and sweet, awesome. Now let me try if there was this dot val. Okay, that makes okay. If it's all 1 and 1 and 1, that's okay. Sounds good. So there can't be duplicate values. Okay, sounds good. All right, thank you for watching, and I'll see you guys tomorrow.